All right, let's start section 2.6. We're going to use our truth tables to analyze some arguments. Okay. All right, so first things first, before we do that, we need to be able to symbolize an argument. Okay. So when we analyze an argument formally, okay, we are just looking at its form. Okay, you're going to see what this looks like, and to do that, we need to symbolize the statements in the argument. Okay, so let's take this simple argument. Jasmine must either go to work or find a substitute. She can't go to work, therefore she must find a substitute. So there are two premises. The first one is Jasmine must either go to work or find a substitute. Okay, the second one, she can't go to work today. She can't go to work. Okay, so what's our conclusion? She must find a sub. Okay, so that's our argument. Okay, now we want to symbolize each of these statements. Okay, and in order to do that, we have to identify the simple statements that make these up. So what's the first one? Going to work. I'm going to say Jasmine must go to work. Must go to work. Okay, and the other one is Jasmine must find a sub. So those are really the only two statements that we have. Jasmine must either go to work or find a sub. She can't go to work, so that's this. I'm going to call this one P and this one Q. Okay, so my first premise is what? She must either go to work or find a sub. So it's either P or Q. Okay, Jasmine must either go to work or find a sub. Okay, she can't go to work, so that is the negation of P. Okay, and our conclusion is she must find a sub. So our conclusion is Q. Okay, so our argument looks like this. P or Q and not P, therefore Q. So we draw a line under the premises, and then we use the symbol, these three dots, to indicate the conclusion. So this is the form of that argument. P or Q, not P, therefore Q. All right? So we've just symbolized that. Okay. Now we're going to look at a truth table to see what this thing looks like. Okay. All right. So we know that there are two simple statements. Okay. So there are going to be 4 rows. I'll say 2 squared. Remember we talked about that. For every simple statement, there's 2 rows. So 2 times 2 is 4. Okay. We have 2 simple statements, P and Q. So we start with 2 trues, 2 falses, true, false in the Q column. Okay. Then I just take each premise at a time. So my first one is P or Q. All right. So P or Q would mean that one of these have to be true. So this is true. Okay. As long as one of them are true, this is true, and this is false. Okay. The negation of P is just the opposite of this truth table. So this would be false, false, true, true. Okay. And then our conclusion is Q here. So you see, we're going to just kind of copy what we have over here. This is true, false, true, false. Okay. So if the argument is valid, that means that the conclusion must be true when the premises are all true. Okay, so determine whether or not we're going to look at each row in which all the premises are true and ensure that the conclusion is also true. Okay. So in the first row, what do we have? Here's the first premise. Okay, it's this one. And the second one is this one. Okay, so in the first row, the second premise is false. Not P is false. Okay, so we don't even need to look at the conclusion. Okay, again, they have to both be true in order for this to be true. In the second row, true and false. Again, not P is false. So we don't even have to look. In the third row, we have a true and a true. So now the conclusion must be true, and it is. Okay? And then in the fourth row, so this is all true. So that's a good one. In the fourth row, first premise, P or Q is false. Okay, so I don't have to look at anything. So is the conclusion true whenever all premises are true? Yes. So the argument is valid. Okay, so that's how we're going to use our truth table. Or one way we're going to use our truth table to determine whether or not these arguments are valid. Okay? Okay. All right. Then we get into indirect reasoning. Okay? This argument uses a form that we're going to call indirect reasoning. All runners are athletes. Lydia is not an athlete. Therefore, Lydia is not a runner. Okay? So before we start analyzing this, we have to identify. Well, I'm still taping, even though I dropped my phone. So I gotta be a little bit more careful. All right, sorry about that. So, in order to do this, we have to identify each of the premises, and the conclusion. Okay? So if we look at this, one of these is all runners are athletes. Okay, and the second one is Lydia is not an athlete. Okay, so what's my conclusion? What are we trying to conclude? Lydia is not a runner. All right, so the first premise is what we refer to as a universal statement. All runners are athletes. So in order to symbolize it, we need to instantiate it, okay, or apply it to an individual. In this argument, we're dealing with Lydia, so she is the individual we're talking about, okay? So this becomes if Lydia is a runner, then she is an athlete. Okay, so that's how we're going to deal with this. If Lydia is a runner, then she is an athlete. Okay, so my two simple statements are P is Lydia is a runner, and Q is Lydia is an athlete. So we can symbolize our argument like this. Okay, if Lydia is a runner, then she is an athlete. Okay, she is not an athlete, so she can't be a runner. Okay, so P implies Q, not Q, therefore not P. Okay, so again, we're going to do our truth table. Notice I have a column for each one of those. Okay, so for a conditional, if the first one is true, the second one has to be true. That's true, that's false, and if the antecedent is false, this is automatically true. Okay, not Q is simply false, true, false, true. Okay, so these are my two premises. Not P is just the opposite of this, so it's false, false, true, true. So that's my conclusion. So examine all the rows where both premises are true. Here it's not. Okay, so I don't need to do anything. Here it's not. I don't need to do anything. Here it's not. I don't need to do anything. So really the only place that it is down here. Okay. So according to this, the fourth row, where P is false and Q is false, is the only one where premises are both true. And in this row, the conclusion is true. So we conclude that the argument is valid. Again, I'm only looking at the rows where both premises are true. Okay? All right, so this is kind of an indirect reasoning, primarily because we have this statement, if P then Q, and we know not Q. Okay, so that's why it's indirect. It's not, you'll see the direct one in a minute. Okay. All right, so if I look at some common valid arguments, okay, now these are just the form. We can prove these if we want to, but it looks like some of these are going to show up in the homework. Okay, I'm just going to give you the less formal names. Okay, this is a direct proof. If P then Q, we know P, Q must happen. Okay, if P then Q, and we know P is true, then Q must be true. Okay, this next one is the one we just did. This is the indirect reasoning. If P then Q, not Q. So again, this says if P is true, Q must be true, and Q isn't true, so there's no way that P could have been true. Okay, because if P were true, then we would have had Q. All right, this next one is the transitive proof. Which hopefully is pretty straightforward. If P then Q, if Q then R, so it stands to reason, if we have P, Q must follow. Since we have Q, R must follow. So P automatically leads to R. Okay, that is the transitive proof. This is the disjunction proof. If we say P or Q, and it's not Q, it must be P. So if we say today is Monday or today is Tuesday, and we know it's not Tuesday, the only outcome has to be that it's Monday. So if you have an or statement and you know one of them is not true, then it has to be the other one. Okay? All right. This next one is called a dilemma. So we have either P or Q. Okay, so we have one of these. P leads me to R, Q leads me to S. So since one of these has to be true, R or S has to be true. It has to be one of these because I know I have P or Q. Okay? And then this last one is called the disjunctive elimination. Okay? So here I have P or Q, so I know I have one of them. P leads to R and Q leads to R. So it doesn't matter if I have P or Q and they both lead to R, my conclusion has to be R. Okay, so these are really the forms, I would have this out when you're doing your homework because these are the forms you're really going to need. Okay? All right. So let's take a look here and see what happens when an argument is not valid. Okay? If you do the homework, then you will do well in the exam. You did well in the exam, therefore you must have done the homework. Okay? So again, our two premises, if you do homework, then you will do well on exam. Okay? That's our first premise right here. Our second premise is you did well. Okay? And our conclusion we're trying to make here, you must have done your homework. You did your homework. Okay? So my simple statements are P, do your homework. And Q, do well on exam. Okay? So just like we've been doing, we look at our premises and then we make our simple statements. So the first one is, if you do the homework, then you do well on exam. So if P, then Q. You did well in the exam, so I know Q. Can I conclude P? Okay? So again, let's do a truth table. P implies Q. That's my first premise. P is true, Q is true, that's good. P is true, but Q is false. That's the one where this truth table is false. Here, the first statement is false, so those are automatically true. I know I got a Q, so I got true, false, and then how about P? It's true, true, false, false. So I really just recopied those last two statements. Okay? So if I look, first row, they're both true, P is true. That's good. Second row, they're both false, so I don't even have to look here. Third row, they're both true. Okay? And then in the fourth row, I have a false, so it doesn't make any difference. So in the first row, where they're both true, both premises are true, and in this row, the conclusion is true. So far, we would have been fine. But in the third row, where P is false and Q is true, they're both true, both premises are true, but the conclusion is false. Okay? And we can't have that. So we say that this argument is invalid because when P is true, nope. You gotta look at the row. When P is false and Q is true, again, I'm in the third row here, the premises are both true, but the conclusion is false. Okay, so that is an invalid argument. Okay, so some of the ones that look like this, and again, if you remember that last page we did, here are the common valid arguments. Here are the common fallacies. Okay, these are the ones that don't necessarily work. So this first one is called denying the antecedent. Okay, so here we know that if we have P, then we go right to Q. If P, then Q. We know the negation of P, so a lot of times we try to think, well, if we don't have P, then we don't have Q. But this doesn't say the only way to get to Q is P. It says if we have P, then we'll have Q. Not having P doesn't really tell me anything. Okay? So this should be no conclusion. All right? I can't do that. This is a fallacy. We try to make that all the time. Okay? The one we just looked at, this was the affirming the consequence. That if we have P, then Q, and we know Q has occurred, a lot of times, again, this is why it's a fallacy. We think, well, if Q occurred, P must have. But again, if P then Q doesn't mean the only way to get to Q is P. It means if P has occurred, then Q must. I don't know anything about P. Okay? All I know is that Q occurred. P could have occurred or not. So again, this is no conclusion. You got to be careful with that. Okay? Faulty transitive logic. Okay, here we have P implies Q, Q implies R, so we know that P implies R, but again, it doesn't go backwards. R doesn't take me to Q, and Q doesn't take me to P, so this is bad, okay? Faulty transitive doesn't go backwards, so be careful. Faulty disjunctive. Here we have P or Q, and we know P, but that doesn't necessarily mean that Q didn't occur, so we could have a not Q, okay? In order to use disjunctive logic, if we know P or Q, we need to exclude one of those. So if it's P or Q and I know it's not Q, it has to be P. But if it's P or Q and it's P, I don't know, it could be Q or it could not be Q. Could be both, I don't know. Okay? So I can't use a disjunctive like that. I have to negate one of those in order to use that as logic. Okay? All right. This is a little crazy one. So this says Jane or Kate will take your order. If Jane takes your order, it will be delayed. If Kate takes your order, it will be incorrect. Therefore, your order will be either delayed or incorrect. Okay? So I have three premises. Let's see if I can maybe use a different color here. The first one is Jane or Kate will take your order. Okay? Either Jane or Kate will take your order. In green here, if Jane takes your order, it will be delayed. And then let's see, I think I got blue. If Kate takes your order, it will be incorrect. So that's my third premise. Therefore, your order will either be delayed or, I got black marker. Therefore, your order will either be delayed, I'll just underline that, or incorrect. And that becomes my conclusion. Okay, so my simple statements are Jane takes your order, Kate takes your order will be delayed, or your order will be incorrect. So the first premise is that P or Q. The second premise is P or goes to R. Okay, if Jane takes your order, it will be delayed, so P goes to R. If Kate takes your order, it will be incorrect. Okay, and then my conclusion is your order will either be delayed or incorrect. Okay? So this uses the argument called the dilemma. The truth table for this argument has 2 because there are 4 simple statements. I'm going to have 16 rows. Okay? Which we have here. We're not going to ask you to come up with this truth table. Okay, so something like this you'd be given. But let's see what happens. These are all my premise. You know what? I marked them with a P. I want to use a different symbol. I'll just put a circle above them. Okay, those are my 3 premises. So all I really need to do is look at the rows where all 3 of them are true. So it's here. These two rows. Let's see, there's a false, there's a false. Here's one where they're all true. False, all true. False, 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 false. Okay, so these are the rows that I need to be concerned with. So remember, a valid argument, if all the premises are true, the conclusion must be. So here, we're good. Here, we're good. Here, we're good. Here, good. Here, good. So this is a valid argument. Okay? So we see that in all of these rows, the conclusion is also true. So this is valid. So this was one of the ones, I think, on that earlier page that I told you to, kind of know these forms. These are the forms of valid arguments. So have this out when you're doing section 2.6, okay? And really moving forward, because these are going to be the valid arguments. Once we get them in this order, and these symbols, we'll be able to tell whether they're valid or not. Okay? All right. I think that is all of section 2.6. So that ought to get you going. Good luck.